I see this two capacitor here doesn't look like healthy. This one and this one. So let's take the cover and see it more. Whoa. This is a lot of bad capacitor. We have this one here is bad. This one here, that's in the power supply. And then the main board, we have this one and this one. Okay, let's write a list what we need. 2200 10 volt. And we need 1000 10 volt. $1,050 volt. This one here should be 1050 volt. So this one is 2. Yeah, I can't find these two here is 50 volt. All I do have is a 35 volt. So in the power supply we have just one transformer. This is a switching IC, and we have the MOSFET to cut the power to the transformer, diodes, the optocoupler, and the TL400. That's not the TL. So what's that? Yeah, usually the optocoupler is connected to TL431. Yeah, it's here. The 431 is here. And we have the filter diodes, capacitors, and that's all. We got 32 volt, 5 volt. And here we have 38 volt in this pen here. 15 volt, 12 volt. So let's move this capacitor. This capacitor just for the amplifier side. already replaced the capacitor, and let's check if we have the voltage. Okay, the multimeter and the DC. As you see in this connector, we have ground, 5 volt, 23 volt, F plus, F minus. So put this one on the ground, this metal piece here. Then we check in the 5 volt. So we have 5 volt is good, stable. 23 volt. We have minus 4 volt. Minus 3 volt. And minus 4 volt. So these voltage are not right. This power supply, it has one transformer. It's here. Yeah, this power supply, it has one transformer. And this transformer, it will give all the voltage when we plug it to the power. It's not like the power supply that has two transformers, one for the standby and the other one is for the other voltage, 12 volt, 24, 30 volt and more. So that time the power board, it will, when you plug it, the standby transformer, it will work, it will give the standby voltage, but the other voltages as 12 volt from the second transformer, they're gonna be in hold till you press the power button. And this power supply is a different case. All the voltages, they should be on. It's not like the TV power supply. Because we have one transformer and we have one MOSFET. So to get the 5 volt, this transformer should work. When this transformer is it works, all the other voltages is going to be on. So let's put this one ground, check in this transformer. We have one, we check on this output diode, we have 1 volt. Minus 2. .8 volt. Yeah, these voltages are not right. Each volt here. Each volt. In this gray connector, there is 12 volt ground, PC, 5 volt, 5 volt, 12 volt, 12 volt, and 15 volt. This connector, this one is 38 volt. So on the 38 volt, what we have, 8 volt. So do we have 5 volt here? 1 volt, we don't have 5 volt. Minus 12 volt, minus 2 volt, 15 volt. And then the 12 volt, we have 3.8 volt. We check the voltage on this main capacitor for the primary. We have 160 volt. So it's good. The rectifier bridge, they are good. That's why we have 160. But now we use the solder iron plug to discharge the capacitor. So let's see how much. So the capacitor now, which has 0.3 volt. 0.5 volt is good. Alright, now we're going to check every single diode. go to the diode mode. Point 3. Point 3. Again. Point 3. Point 3. So X on this diode, because we need to check it after we remove it from the board.
I'm gonna go
Okay.
to the battery place.
Okay. So there is a diode here. There is another diode. And we're gonna flip. We have 0.7. Let's check the output diodes.
See ya.
See ya. 0.4 if we flip. So is that open? Good. 0.4, and if we flip, it's open. Yeah, that's good. This one here, 0.2. The other side, it's open. It's 0.7. This one, 0.2. Or 0.4. And we're gonna flip. Point 1. Point 4. Point 1. Point 4. Point 1. Point 7. Point 4. These two diodes, X on them, because we're going to need to check them after we remove one side. So 0.3. Still going up. Okay, look like this diode is good. So still going up this one. It's like we charge the capacitor, that's why the number they keep going. But this one looks good. 0.3 this way. and over 1 volt. There is another diode, this one, 0.2, 0.5, 0.2, or 2.5 this way, 0.5 this one. So let's see the first one we check. Point 3 this way. Point 3 this way. Look like this is a VCC diode. Could be. So 0.4 is good. There is 2 diodes on series here. 0.4. Open. And the other diode is here, this one's. So open this way, 0.4. Open and 0.6. Zero 0.05. That's low. 0.05. I think this diode and the resistor is connected on series. Yes. So when we are measuring the diode, like we are measuring the resistor, these 2 pins here. So another for this diode. Okay, good. The rectifier bridge, 0.5. Open. 0.5. And open. 0.5 and open. The MOSFET should work fine. Is working fine because we have 5 volt. So there is a chance could be the IC. This switch in IC here. Alright, let's remove this diode and we test it. This one here. Yeah, I think this diode here this diode is on parallel with resistor. Yeah, this is the ones. So what about these two diodes? 0.4 let me take the diodes and so 0.1 open, so the diode is good. 0.4 open. Yeah, so the two diodes are good. So what is could be the problem? Let's be sure that there is no bridge, because the pins is very close to each other. So in this case, the diodes are good here in the cool side or secondary side. The primary side it works, but Colby is not working right. Let's check the optocoupler. This side should be a diode. Because sometimes the feedback circuit, they do this one. They do these problems, the voltages is not coming out right, because the feedback is not working as it should. So 2.6. .8, yeah, look like it's right. Any shirt. And here there is a, in this side, there is a half transistor. So 2.7. And open. Check all the resistor. switch to the diode mode. We have this is a transistor here, and another transistor, plus the TL for the feedback. Like this transistor is, this transistor doesn't test right. Definitely. So the transistor, this one here, gonna check it out and test it. Yep, this transistor is shorted. See that? Yeah, when you see this testing mode, it means all the probes are connecting together. Yeah, this transistor is bad. I can see very low reading in all pins. I'm still gonna need to check the other one. This one right here. You can see EBC is mean emitter base collector. So we should have a reading from the base to the collector, then from the base to the emitter. If we flip the probe, we should have no reading or higher reading from the base to collector, from the base to emitter, higher reading from the emitter to collector. So this is a normal reading from the base to emitter, from the base to collector is a good CH 0.6, and we're going to flip. We put the black probe in the middle one. Here we should have a higher reading or no reading. Is a 2.3 volt and still going to here 2.8 volt and still going. That's good. And from here to here, the base, the emitter to collector 1.6, and we're gonna flip 1.4, so over 1 volt. So this one is good. Same thing, this one, the base is in the middle, so we should have a reading this way, we shouldn't have a reading or higher reading this way, and we shouldn't have a reading this way, but I don't know. Okay, it means this is the one that we need to check it too. Or this is a BGT, the transistor. Let's see if you can see it clearly. You can see there is a transistor and there is another diode. That's what is make the reading strange. See how they set up it? Okay. But this one is good. Okay, I'm gonna look for this transistor, something equivalent to it. Then we go from there with the number here. So BR N, you can see that crack, N5401.